It's still a wonderful day to be looking at these wonderful mathematical topics, and we're going to go a step further with our linear regression, and we're going to measure how good, how strongly linearly related two variables are. And the way we're going to do that is by looking at its correlation, and it's measured using something called the Pearson product moment correlation coefficient, usually just called the correlation coefficient. And its abbreviation is R. Why we use R instead of P for Pearson, who knows? I really don't, and really it's not that big of a deal, but just know that it's R. And it's measuring the correlation between X and Y, that is how closely linearly related they are, and we'll get a value between positive 1 and negative 1. Remember, a correlation of exactly 1 means it's a perfectly straight line. So here are some scatter plots with their correlation coefficients. Perfect linear correlation with a positive slope has a correlation coefficient of 1. No correlation is 0. And perfectly negative, that is, all points are collinear with a negative slope, the correlation coefficient is negative 1. Here are 4 others, and you should notice that all of the slopes with positive correlation have a positive correlation coefficient, and similarly the negative ones. Now, how do we determine what this is? It's similar to how we came up with the slope in the previous section, but here's the formula for R. It's S sub xy divided by S sub x times S sub y. It's very, very similar, but now we're not doing S sub x squared on the bottom, we're putting sy in there. And notice the formulas here for sx, sy, sxy. They're all really the same. They're all from the previous section. We use them both ways. We use them for finding the slope of our regression equation and for finding our correlation coefficient. And a rough description of how strongly correlated things are is according to this table. Strong is 0.75 to 1, moderate is 0.5 to 0.75, and anything under 0.5 is considered weak, with 0.25 down to 0 being very weak. So let's use this wonderful bundle of joy to find our correlation coefficients. So we have, or we want to know, if we look at the number of spoons of plant food I use and compare that to the extra number of orchids grown from a plant, how strongly correlated are these and what's the relationship here? So we want to find our correlation coefficient. So we have this table. We need to find x times y and add them up. We need to add up the x's, add up the y's. And we need to add up the x squareds and the y squareds also. So here's our xy's, our x squareds, our y squareds. We add up those columns and we get these values. So here we go. We're going to calculate R. So R is equal to, in the numerator, sum of the xy's, so 60, minus sum of the x's, 10, times sum of the y's, which is 20, divided by n. N here is 1, 2, 3, 4. We had 4 plants that we gave this plant food to. And then on the bottom we have s sub x and s sub y. So it's going to be the square root of sum of the x squareds, that would be 30, minus sum of the x's squared, so 10 squared, divided by n, which again is 4, and then multiply that by s sub y, which is the same formula as s sub x, except we're replacing the x's with y's. So 126 minus 20 squared over 4. And we run this through our calculator. So this isn't something that we calculate by hand. We plug it into some sort of a calculation device, and we get 0.877. Now we can see that this data is fairly strongly correlated. This is greater than 0.75, and it has positive correlation. Its slope is going to be positive. So we had to use the calculator anyways. So anybody thinking, well, why didn't we just use our linear regression calculator in our calculator? So let's go back to our calculator and look at this. Let's look at the example from last time. There's our graph. Here's our data from last time. And we had our equation. We've got m, we've got b, slope, y-intercept. And then we have r. For this data set, our correlation coefficient was 0.79. So we could say that this data is strongly correlated, strongly positively correlated. And the regression equation is given by 0.117x times plus 0.833. So all this information is right here when we do our regression calculation. Again, to find that, while you're in the table, you go Menu, Statistics, Stat Calculations, and choice number 3. So that's all we have today. It's very calculator-centric. If you don't have a graphing calculator for these sections, you're going to be doing quite a bit of mundane calculations and using up a lot of time that you could be using for much better things.